As we walk towards the house, I noticed these black panels below the basement windows.
Yeah.
Explain what those are.
Those are solar hot air panels. They bring in the room temperature from one end. It goes across horizontally to exit the other end, and in that 7 feet, you're going from possibly 68 degrees to putting out 160 degrees on each one of these panels.
Okay,
They're worth 20,000 BTUs per hour.
right. And you have them on the west-facing side as well.
So I have 7 of these.
7 of these, and of course they're turned off in the summertime.
Correct.
They're blocked. That flow is blocked.
And notice all these windows are shaded in the summer from May 5th to the end of August. So in 1981, this was well insulated above its date with R19 walls. But after taking the Theus Passive House college courses, I realized I'm way out of date. And so
Look at all these wires.
this is all remote wireless monitoring of the electrical circuits, so that I can get warnings on my phone for insulating up to the Passive House standard. If you walk over behind me, you'll see exposed here. Here's the original 1.5 inches of polyiso from Australia, and here's 8 more inches of polyiso that I added in 2015.
Yeah.
By adding the walls up to R55, I was able to remove the backup gas furnace. So part of the logical SARI design of any passive house is to have minimal windows on the north, east, and west sides. Windows are like a hole in the wall. You'll notice that the roof of this house has no chimney. That tells you that we are a modern house that doesn't have fossil fuels. I use a mini split that's very minimally on, only 500 watts when it's needed. We'll have some daylighting from solar tubes. We'll see those on the inside of the house.
Now we're approaching the airlock. Airlock entry prevents north wind from entering the house.
As we stand here, this is the environmental monitor computer that's running the house. There are over 180 endpoints in this house that it can control. Each one of these graphs is 5 days of window temperatures. That's how the computer knows when to raise and lower the shades. The sun's solar radiation over 24 hours, 5 days of sun here.
Wow.
And so we'll learn. You can learn more about this when you come to visit me. I'm always open to the public.
This is that thermal mass.
Yes.
Yeah, this is inside this brick structure is more mass, rocks, and so this thing during that winter month gets heated up by the sun.
A thermostat that's in behind the grill, and it's going to suck that hot air off the top of the house down through a 14-inch diameter chute to the basement.
Where does the air go into the thermal mass? If
Down
that's
basement floor.
on the basement floor. Okay, so okay.
And so here's the top of that rock box.
Oh yeah, you can actually
So
see.
that is 10 feet deep of river rock. Currently 70 degrees. This is the cinder block box itself, containing the box.
Wow.
And so that's 5 feet by 5 feet by 10 feet deep.
And then there's another one over there.
That's the back side of the box. Yeah.
Oh, okay.
There's 3 of these vents. So this is the escape of the air that was sucked off the ceiling.
I see.
So that's warming up the rocks, and the air comes through cool here of whatever temperature the rocks are.
Good.
In the wintertime, the rocks will achieve 78, 79 degrees.
Wow. Oh, there's the mini split up there, which is really only backup, right?
Correct.
And that's powered by a heat pump, which is outdoors.
Yes, and powered by the electricity from the solar panels,
Of course, yeah, because you probably generate more electricity than you use.
Correct. Yes. The clear story windows up there. These 2 left windows have a pattern on them. The 2 right do not.
Oh, why is that?
This is new technology from Alpen. If the sign on the brick says sun redirect film, and just like you have light shells that reflect the light deeper into a room in high-tech office buildings, Alpen says, why not do that with laser etching? So there's microscopic horizontal lines that will take the winter sun and angle that 90 degrees up to the roof.
Wow.
And then if you have a reflective roof, it's lighting up the deeper ends of the room.
Wow.
But the heat pump is the highest tech one available. It is SEER 42 and a heat efficiency rating of 15. This is a whole new generation of efficiency. And this heat pump will keep heating at minus 17 degrees Fahrenheit at 100%.
Yeah.
We want to explain the windows here.
Oh yeah. Here's
Alpine windows are the next thing. In addition to super insulation, we want quadruple pane windows. These are filled with krypton gas.
and those two middle panes are not glass, though, are they? Aren't
In
they?
this case, it actually is thin glass.
Oh, it is, because the triple pane has a filament in it.
Yeah.
Or
You can get filaments or thin glass nowadays.
yeah, okay.
And the frame is filled with foam. The NFRC, every window manufacturer must be qualified by the National Fenestration Rating Council. And the U factor of these is 0.10. That is a huge R factor of R10. These glass windows, center of glass. This one is R17. This is a low solar heat gain. That's a high solar heat gain with a center of glass of R13. Again, you could build a whole house out of this that's better than all these neighborhood houses.
Okay.
Alexa, turn on outside shades.
Oh, you use Alexa to lower your shades?
Yeah, I've had voice control since 2004
Oh, wow.
using the Microsoft version originally. So you can still see through the netting. That's what I wanted
Yeah.
to point out.
Are these 90%, 80?
I believe they're about 70.
Oh, okay, yeah. Yeah, now normally they are, although you can tell Alexa to raise and lower them, they are programmed, the computer tells it when to lower or raise it, especially in the winter. That's when, I guess, it's more of an issue.
So the houses of the 1981 vintage tend to overheat.
Yeah.
And this will keep you from overheating. And a few years ago, we had 80 degrees in November and 80 degrees in February because of global warming. So I was forced to have outside shades to regulate. Nothing is seat of the pants here.
Yeah.
And then inside, so the computer's already automatically raising this.
Oh, really? You didn't tell Alexa to raise them. The computer said, no. These should be up right now.
And
Interesting.
and this is the internal shades. Alexa, turn on door shade.
Cute.
These are the inside shades that reflect the heat back in the winter time. They will go up when there's sun to be had to warm up the house. And when the clouds come, the shade comes down. Keep that heat in the house. Don't let it get out.
Okay, the computer just raised it again.
Yeah.
Computer said that wasn't a smart idea.
You bet. This room has hot air coming from the hot air panels outside. It's sucking in. Sucking in the room temp air there and putting out superheated air at your feet, so you have toasty, warm toes in the winter time.
behind the
Yeah,
sofa.
those are putting out 160 degrees. Here's the bathroom one. The sun is hitting that one.
Yep. So there's no lights on in this bathroom.
Correct.
Well, now there is.
Yeah, it's automatic light.
Yeah.
And up behind here is a fake fascia for the bathroom fan. So the
Oh, I
fan
see.
is hidden behind.
Oh, you've integrated the fan with the solar tube. Okay.
If I'm bringing in outside environment to the fresh air machine, why not make use of that outside energy
Yes.
for a heat pump?
Yes,
It's
right.
a logical-
Okay, so you're going to show us the.
Yeah.
Or,
So physically,
okay, I'm on my knees here.
because this is a retrofit house, I'm making use of the old furnace system. So I'm sucking
Oh,
from...
the ducts.
Uh-huh.
The duct work for the forced air furnace is being used by this CERV.
Yeah.
Yeah.
So all the ducts that used to feed hot air to the bedrooms are now sucking stale air out of the bedrooms.
Right.
They come into one of these tubes and they are exchanged with fresh air, which puts out, you saw the duct above the kitchen refrigerator.
Yeah.
And also there's a duct feeding the basement right here.
Yeah.
You can hear it.
Yep. Yeah. You can actually hear the sound of the air coming. This is coming in here, right?
That's fresh natural air.
Fresh natural air here. Yeah. Okay.
In the winter heating mode, it can add heat, and that'll be putting out 112 degrees.
Okay.
Here is a graph that shows the VOCs, CO2 levels, relative humidity outside, inside, temperature outside, inside. And so if you have a sudden spike in VOCs, the shaded area shows how the CERB engaged into high speed, and it's bringing in fresh air to bring that VOC back down under 1,000 parts per minute.
Yeah.
Per minute. Yes.
You use this home theater for teaching about sustainability, don't you?
I sure do.
And how often and where can people find out about it?
So once a month, I hold the theus.org presentations. I try to
Theus
get
is PH.
Passive House, United States, Institute in the United States,
yeah, okay.
US. And once I am the Southwest rep of theus.org, the schedule is at meetup.com,
Meetup.com. Look for
Passive House Southwest, SW.
Passive House spelled out and then SW. Yeah.
And I might also add that I got started by becoming a member of your state chapter of the American Solar Energy Society.
ASES.
And Colorado has Colorado Renewable Energy Society, CRES. And if you want to escalate your knowledge of renewable energy, join CRES.
Yeah. Well, this has been an amazing experience. You were quite a teacher, and you've made your home into a real classroom, and we can all be thankful that John Avenson is doing this. So thank you for that. Do you want me to tell people your email address?
Yeah, avenson1@hotmail.com.
Okay, so they can call you, they can email you if they have further questions.
The garage is a 40 amp service for a Tesla. Someday when I can afford one.
Meanwhile, you're spending all your money on this learning center.
Yeah.
Yeah, right. So you've done a lot.
I also have an outlet for electric cars at the front of the garage so my guests can plug in and get back home on their charge.
Oh, okay, great.
Every house should be built with that.
Yes.
Think of others.
Yes, right. Well, thank you again. This has been quite a learning experience, and I thought I knew a lot, but I learned some more myself.
All right.
Thanks.